Welcome back, y'all. Today we're moving on to lesson number 4. You should have just completed the basic interest rate lesson. So now we're going to move on to one of the more complicated lessons titled Compound Interest Rate Formula. And the objective today is students will be able to calculate future value and present value using the compound interest rate formula. So let's dive right in real quick to get us started. So if you recall from last class, this is the formula you learned. You do not need to retake this down. I just want to remind you of it. And this formula said that the future value of your money, if you deposit your money in a bank account, can be calculated by taking the original amount, multiplying it by 1 plus R being your rate of change, percent rate of change, your interest, and raising it to the T power being however many years you leave that money in the account. Now this big note here is important. This formula assumes that you will receive your interest at the end of each time period. So it's compounding yearly, meaning you're going to get your interest once a year at the end of each year. So after 1 year you'll get it, then after 2 years you'll get it, then after 3 years you'll get it. But that's not actually how the real world works. So how does compounding interest rate work? So what is compounding? Compounding is earning interest on interest. It is the reason why interest earned increases over time. So the reason why your interest increases over time is because you're earning interest on the money you earned the previous year. So the more you compound, the faster your money grows because the more interest you're earning. Now APR is your annual percentage rate. That's the interest rate charged per year. So if I have a 7% APR, that means I get 7% per year. 10% APR, 10% per year. However, this last concept is arguably the most important, compounding period. Compounding period is how often the interest is received per year. So your APR may be 8%, but it could be compounding monthly, meaning you're going to get a little bit of that 8% every single month. This idea of compounding, earning your interest more regularly, increases how much money you earn. And it also changes our formula. So our new interest rate formula, titled the compounding interest rate formula, starts out the same. It says your future value of your money is going to be equal to the initial amount you deposit times 1 plus, and this is where you start seeing your first change, your rate, your APR, but you're going to divide your rate by the amount of times it compounds in a year. So if I'm going to get 8% interest, but I'm going to get it monthly, then I'm going to take my 8% and divide it by 12 to see how much my interest is per month. Now, similarly, I'm not going to raise it to just the T power, but I'm going to raise it to the T times N power, N being that same variable you see down here. So if I'm going to get paid monthly, then I'm not just getting paid 5 times if I leave my money in 5 years. I'm actually going to get paid 5 times 12, 60 separate times if I leave my money in an account for 5 years, but earn it monthly. So here are the key changes. You divide your rate by N and multiply your time by N. Now, how does this play out in a real-life example? Well, using a very similar example to the one we used last time, when Denise decided to go to her local bank to deposit $800, she realized that she actually had more than one savings account option. You don't just show up at the bank and say, here, take my money. They're going to give you a few options. And using your knowledge of compounding interest, determine which savings account option will earn more money after 2 years. So here are the two options that have been presented to us. You can get an account that pays 6% APR compounded yearly, and that keyword there is compounded. Or you can take an account that pays 5.9% APR, but this time it's compounded monthly. So we're going to use the formula we just learned, which is P times 1 plus R over N raised to the N times T power equals F. But we're going to calculate it for option 1 and option 2 and see which one is better. Now initially most people would say, well, obviously option 1, it has a higher interest rate. But the fact that this one compounds more often may change your answer. So let's start with option 1. If I substitute all the necessary information in my formula, it looks like this. 800 times 1 plus, there's my 0.06, that's my rate, divided by 1. And the reason why it's divided by 1 is it says compounded yearly, meaning you're only going to get paid 1 time a year. So my N is 1. Similarly, up here, my exponent is 1 times 2 because it's compounding 1 time a year, and I'm leaving it in there for 2 total years. So it's 1 times 2, leaving you with an exponent of 2 in total. When I simplify the formula, this ends up becoming 800 times 1 plus 0.06 because 0.06 divided by 1 is 0.06, and 1 times 2 is just 2. When I type this into my calculator after I add the 1 and the 0.06 and raise it to the second power, I find out my account will be $898.88. So that's my option 1. I'm going to have almost $900 at the end of year 2 using option 1. Now let's take a look at option number 2. Option number 2, when I do the substitution, I'm going to get 800 times 1 plus 0.059 because it's 5.9% APR. But this time I'm dividing it by 12. And the reason I divide it by 12 is because it's compounded monthly. So I get my interest 12 times a year. But similarly, I'm going to leave my money in the account for 2 years. So that means I'm going to get paid 2 times 12 times because I need to figure out how many months are in 2 years. When I simplify this, I get 800 times 1 plus 0.004917 raised to the 24th power for the 24 months in a year. Now, there's something you should notice here. The first thing you should notice is you receive your interest 24 separate times in 2 years. In option 1, you only receive your interest twice, 1 time for each year. It's compounded yearly. But option 2, you receive it 24 times because you receive your money once a month. There's 24 months in 2 years. On a flip side though, every time you get your money, you're only receiving 0.49%. That's very small. You're receiving a tiny bit of your money every single time you receive it, but you're going to receive it 24 total times, not 2 times. Let's see how this affects our total account balance. Well, if I run the actual numbers, I simplify the formula, type it into my calculator, I find out I get $899.93. While this may be a small difference, it's clear which one is better. It's clear that option 2 is better. And the reason why it's better is not because my interest rate is higher. In fact, my interest rate is smaller. But because we have compounding more frequently, we are earning our interest faster. And by earning your interest faster, your account grows faster. That's all I have for you guys today. Good luck on the assignment.